This is one of the first videos of a series that we decided to do for projects. We do know here at BMES that we will keep going with projects like OPBGO, and ever so often we will get a more sophisticated case, or we might decide to take on more sophisticated cases for future projects. So that means we're probably going to be using, instead of just very simple wiring and mechanics, we might have to create our own devices, or at least design our own systems with things like Raspberry Pi and Arduino, include different modular objects and tools and the such. Therefore, we decided that as we learn about these, we're the first time working with them in our own projects, it would be good to keep documentation. This PowerPoint-slides thing should be in the BMES drive. So if you see this video and you want access to read it or whatever, ask your officers, and it should be safe for them. As far as this video, it's just the beginning, commencement of this idea that we had, that whether it be an Arduino or a sensor or a motor driver, that we would have a very quick video explaining more or less the basics of how it works and what you use it for and the such, so that projects in the future can be built upon this very basic stuff, or that if more advanced things are done, that you at least have this as a reference guide. So yes, making it easier for future projects. So right now we'll be talking about L298N motor control module, or motor driver. So what is this? It looks like this, almost like a pencil sharpener. But in essence, it's a motor controller device that uses an H bridge to control up to 2 different motors. The motors will be connected to each of these sides, but we'll go over that. So the schematic here. First of all, you will see that you have like a plus 12 volt and a ground here. Let's see if I can have a pointer. I want to use pointer. Oh, whatever. The mouse will have to do for now. Yes. So these two are the ones that are used to actually power the motor driver itself and power the motors. These almost 12 volt channel and ground channel. Now, something that I have to mention is that, although not explicitly stated, it is recommended that at least 4.5 volts are used to power this motor module. Anything below 4.5 volts causes usually suboptimal performance of the motors, and if not being powered by the Arduino, not connected to power source, can also create issues with the logic and whatnot. So stick to at least 4.5 volts, 5 volts. You should be fine. Make sure that, of course, it matches the power and the voltage, the power output and the voltage requirements of the motors, of course, not for and your batteries. You can match that up. Secondarily, you have these two connections on the sides: positive terminal with the positive terminal of the motor, of motor A, motor B. Same thing with so negative terminal with negative terminal, motor A. So same thing with motor B, right? Amazing. Then you have this area where these middle four, these outside ones, as you can see, are power connectors. Actually, these can help modulate speed. We will not be talking about that. However, they are helpful to do that. They are not required to give logic inputs to the motors to tell them how to move, essentially. What you need is this middle four. This middle four will be connected to the Arduino digital inputs, and essentially the first two of these will tell the first motor how to move. So for example, if the first pin is defined as high and the second pin is defined as low, then it spins forward. If the first pin is defined as low and the second pin is defined as high, it rolls backwards. You know, H-bridge system. And the same thing for the second two pins, but for motor 2. This, of course, Arduino will be the Arduino will be attached to a separate either analog or whatever you want to do controller for us, instead of doing a joystick, we're using an MPU 6050, which sits on an accelerometer and gyroscope, which essentially is still giving us connected very similarly to this joystick, but instead of taking a signal from joystick, we are taking values from the accelerometer and gyroscope and transforming those into actual parameters and something that works in the algorithm to actually move the motors the way we want them to. Yeah, so how does it work? I kind of explained. You have the motor, the power input here. Have an additional one that you can also connect. But of course, this will power motor 1 or motor 2. Make sure that they're connected properly. One important thing is here, the jumper that must be set is it has a 5-volt regulator. So you want to feed it at least 5 volts of power. 4.5 is the recommended at least. However, when we feed voltages that are greater than 12 volts, we need to make sure that this jumper is deactivated. Very important because it can damage the regulator, making it unusable, and then in the future, and then also maybe cause problems with the chip itself, the whole unit itself. So just be careful with that. Also important thing, have a whole circuit right here. Of course, the power that you provide from outside is not going to be 100% efficiently used. So make sure that if you're using like a 6 and 6 volt motor, for example, or something, to account for that, because there will be a voltage drop. So for example, let's say you feed it a 12 volts as a battery or power source, you might have a 2 voltage drop, which of course will not maximize the spin of the motor. So of course, if you're not trying to go for like the highest power, the highest speed, this is not always a problem. However, if this is something that you're not accounting for and you need all of it, then make sure you do account for this. Yeah, so how does it work? As we explained previously, we have logic inputs. You can pause and kind of see how these specifically work. But essentially, pin 1 and pin 2 control motor A, pin 3 and pin 4 control motor B. These actually control the H bridge inside, so pin 1 is low, pin 2 is high. Sorry, compared to what I said before then. It will spin forward. If it's vice versa, it will spin backwards. The whole point is these are like logic pins. So this is essentially how it works. Pin 1 and pin 2 correspond to the motor A, or the first motor, and pin 3 and pin 4 correspond to motor B. Now, you will see that these ones are connected. They are open for connection. This is where you can actually hook up the power to the Arduino. And we are experimenting, but we believe that you can also alter power and therefore speed of the motors to control that. However, the important ones to control just the rotation itself of the motor is just these main 4 parts. So what's the application, at least that we're doing in this project, right? Sample application. This is actually from howtomechatronics.com, their schematic. They essentially did like a little car that you could control with joystick. For Go Baby Go Spring 2022-Summer 2022, we are doing a similar application. Our recipient-patient has a condition which does not allow her to have mobility of any of her motor muscles, motor organs, or organs that have motor nerves and motor muscles. So essentially, she only has movement from her part of her neck and up, only her head. So we decided that the best course of action, instead of trying to do joystick or things that are not as highly modular and might provide a greater risk of injury, to take this idea, but instead of having a joystick, have a sensor that essentially can measure movement, and we came across an MPU 6050, which is a gyroscope and accelerometer. And the great thing about this is that within it is self-calibrating, so we can place it anywhere relative to the head, and it's not a problem that we have to solve complex tasks of calibration. And the nice thing is that also as she grows, she's not going to have a problem with this. It rests on top of her head. Just every time you initialize the Arduino program, this will calibrate, which is really, really great. Then the schematic works. The MPU will be connected to power source to the Arduino, which the Arduino will be connected to a power source as well. Usually, right now, it's being connected to a computer. And then it will be connected to analog inputs to the Arduino, where it's an output for the MPU, input for the Arduino. Then the Arduino itself will be connected to the logical inputs that we saw before to drive the motor forward. We're still planning on perhaps connecting the power. Since we don't necessarily need speed controls, it will be very, very slow. We are not too pressed, however, that's an option on the table. And then you have the motor driver unit, which we discussed. The logic inputs will be controlled similar to this by the transformation of the Arduino taking these analog signals and sending it out to this other module, which the module will be connected then to a 12-volt battery to power some motors that we decided we care about. So yes, this is essentially a breakdown of the project. We are still in prototype testing stage. And here is a video from How to Mechatronics. This is the title. I will not play it due to copyright and time, because I do seem to be a bit slower in talking than I thought. Opa. Okay, so credits. Thank you. Thank you very much to Mechatronics website, because this is where I've learned a lot of my Arduino stuff, the How to Mechatronics website. And they provide a lot of these very nice diagrams that we had that were not hand-drawn on a tablet, came from their website. They're really, really clear about it. Also, thank you very much to Bernard Lee and Brian McElvey for providing the original idea of using MPU. It's the 50 and kind of talking us through how Arduino, interacts with these analog signals and interacts with the motor driver unit. And for Brian McElvey to making a really beautiful schematic. This one. Thank you very much.